Hello guys, welcome back to school. Here we go, objective 5.1, polar and rectangular coordinates. So we already know rectangular coordinates, okay? You've been always in algebra working with rectangular coordinate. That's the x comma y coordinates. We're learning about polar coordinates, okay, in polar form, and being able to go back and forth, seeing from one to the other, okay? So first, let's learn about polar form. Then we'll go ahead and convert them back and forth. All right, so let's first introduce polar coordinates. All right, so the foundation of the polar coordinate system is a horizontal ray that extends to the right, also known as the positive x-axis. So this is the positive polar axis. We're used to call it x-axis. That's if we're talking about rectangular coordinates. But polar coordinates, we call it polar axis, okay, in same location. This ray is called the polar axis. The end point of the polar axis is called the pole. Not here at the arrow, that's not the end point. The end point is right here, which is called the pole, okay? So the end point and then the arrow, which makes the ray. Now, a point P in the polar coordinate system, okay, so if I have a point P somewhere in the polar system, is designated by an order pair, but it's not x comma y anymore, is a radius and a theta, and an angle. So it's always a radius and an angle. How do I arrive at that point P? You have to tell me how much rotation, what angle I need to rotate, and how far is my radius to arrive at this point. Okay, so the radius is a directed distance from the pole to the point P. So from the pole to the point P is the radius distance. Okay, it can be positive radius, it can be negative. We'll talk about that in just a minute. Or zero. Okay, I can stay at the pole and have zero radius. Can it be negative? Yes. Today, yes, for this purpose here, yes, it can be negative. It's more like I would like you to think as a reflection than a negative radius, okay? When we're talking about circles, there's no such a thing as negative radius, but when we're talking about location, to identify a point P, we can refer to a negative radius as if it was a reflection. Try to think of it that way. Also, the angle theta is an angle from the pole to the point P, so we have to rotate that, and it can be in degrees of in radians, and it can be positive or negative as well. Okay, all right, so that's the introduction with a lot of wording that your book uses right here. So here's what it looks like with a visual. If I was in rectangular coordinate, I would move horizontally first. Okay, we move horizontally first, and then we move vertically. So to identify this point, I would go -1, 2, 3, 4, and then up 2. We're so used to doing rectangular coordinates. In polar coordinates, you use a different grid. Okay, it's a rotational grid. So I have to give you a angle and then a radius. So this point P is at 150 degrees. I'm showing that I went to 150 degrees. And I counted the radius of 6. 1, 2, 3, 4, 5, 6. And there's point P. That's how we represent a point in the polar coordinate. We have to give you an angle, and then we have to give you a radius. Okay? So let's go ahead and start plotting some polar coordinates. We extend the length of the radius and along the polar axis, and then we rotate. I like to rotate first, and you'll understand why. I rotate the angle first, and then I count the radius. Okay, and this is just doing a review. If you go clockwise, it's because you have a positive theta. If you go, counterclockwise, so we go counterclockwise for positive theta. We go clockwise for negative theta. But by now, in advanced math, you should know that, okay? And it's talking about that the radius can be positive. We plot the point at the location of the angle. If the radius is negative, we plot the point 180 in the opposite direction. That's called a reflection. Okay? That's why I said when we're thinking about negative, think about reflection, because you're going 180 to the other side. Okay? So That's just a little introduction, a lot of wording. Let's practice with values. Here we go. So here it is, another example, example 1, plot each coordinate. So if I give you 3 pi over 2, well, 4 comma 3 pi over 2, I would like to look at theta first. Okay, always do theta first. Go to 3/2 first, then count the radius of 4. 1, 2, 3, 4, there's your point. Okay, so you must show that you went the angle of 3/2. Okay, 3 pi over 2. Okay, how about if I give you a negative theta? That's okay. We're going to go negative 2/3. You got to show that you went negative 2/3, the direction of the angle, and then you count the radius of 4. 1, 2, 3, 4, and there's your point. So it's pretty much go to the angle, count the radius, and that's your point. Okay, that's how you do polar coordinates. Let's do a couple more from beginning. So here we go. 210, always go to the angle first and show direction. Okay, show the theta of 210. You've got to show that you went in there. So here is 210. So I'm going to show that I went in there, and I counted 4. So at 210, count 1, 2, 3, 4. There's our point. But I got to show that I went to 210. So let me use my handy dandy marker here. Okay, so starting here, the positive polar, I went to 210. So there is my angle of 210. Okay, negative 75. Let's go to the theta first. Negative 75. Let's arrive at negative 75. So this positive 75, we introduce a little bit more in this circle because it's not the unit circle, but we introduce more angles. Here's positive 75. Follow that positive 75 to over here, 285. Okay, so this is the same as negative 75. Let me go ahead and arrive there in just a second. Let me count the radius of 5. There's 1, 2, 3, 4, 5. There's my point. Now let me show. The point without any direction, without any angle is incorrect. So let me show that I went negative 75. Okay, negative 75 degrees. And there's the label to show. Now, if you don't like it and you don't have the, some people hate the grid. They say it's so much, it makes me confused. That is 100% fine with me. You can go ahead and draw in your notebook. You don't have to have the grid. I actually don't like the grid. I like to show that I went to negative 75 degrees, and then I count my radius. Here's how I show. 1 tally mark, 2 tally marks, 3, 4, 5 tally marks, and I put my point on the top of that tally mark. Some students love that because it's cleaner. Hey, I'm okay with that. You put it in the correct quadrant. That's where negative 75 should be. It's much cleaner without having all of those circles and all of those angles, okay? So I will probably like this better, and I'll probably use this better because it's less crowded, okay? All right, let's do a couple more just to practice. Let's do with example 2, plot the given point in the polar coordinate system. So here we go. Let's go ahead and do on a clean paper instead of the grid. It makes it a lot better. Here we go. So negative pi over 6. Let me put the polar axes. Negative pi over 6. Well, I know that pi over 6 is right here at 30 degrees. So let me just roughly put it right here. It's not accurate. Again, it's not accurate, but here we go. Negative pi over 6. I'm labeling my angle, and I'm going to count the radius of 3. 1, 2, 3. And there's my point. Okay? So negative pi over 6, I need to show that. Okay? I need to show negative pi over 6. There we go. So I show the direction. I label my angle. I put my point. All right. Let's go ahead and do 11 pi over 6. Well, guess what? It is in the exact same location. Let's do it. Okay, there's my polar axes. 11 pi over 6 is right here. Let me label 11 pi over 6. Let's go ahead and count 3 radius. 1, 2, 3, tally marks, put point P. But we got to show that we went 11 pi over 6. So we got to go from here to here. Okay, look at the difference from that to the one I just did a second ago at negative pi over 6. 1, 2, 3. They're exactly the same point with exactly the same radius with different angles. So if you don't show your angle, okay, without the direction angle, you don't have enough information. So please label things nice and neatly. All right? Okay, so that is your 11 pi over 6. All right, let's go ahead and play with negative radius. Okay, negative radius. Here we go. I like my own grid. All right, so I like to think as a reflection. I still start with my angle of 45. Always, okay, plot theta first. Okay, so let me go ahead and do my grid. I'm going to go to 45, which is right here. Don't do it super dark. Okay, 45 degrees. That's the angle that I'm using. Let me go ahead and count 2. 1, 2. However, I am not putting that point there because my radius is negative 2, which is a reflection. Try to think as a reflection. So I'm going to go over here, and I'm going to reflect this tally marks. Tally mark 1, tally mark 2. So my point should be here. Not there, it's a reflection. But do I still go to the angle 45? Yes, I'm still obeying that I went to 45. Okay, I went to 45, but I reflected over 180 reflection. Okay, so my point is actually here with the radius of negative 2. Okay, let's do another one. I'm obeying my angle. Okay, I'm going to plot theta first. Okay, 3/4. So this is 1/4 pi, 3/4 of a pi would be right here. Okay, let me label. That's 3 pi over 4. Okay, and I'm going to go there. Okay, I'm not going to go anywhere differently. I'm going to go to literally 3 pi over 4. Boom. There's my angle, 3 pi over 4. Okay, now let's reflect. So I'm going to put a nice little reflection here. Okay, you do it very lightly. And let's go ahead and count the radius of 3. 1, 2, 3. So my point is actually here. Okay, it's a nice little reflection of the radius that should have been 1, 2, 3. Should have been here. I reflected over here. So I still obey the angle of 3 pi over 4, but I reflected my radius. So it's not negative, it's a reflection. Okay? But it is negative. All right, let's do another one. All right, so here we go. Now I have a negative angle and a negative reflection, right? A negative radius. So let's go ahead and go obey the angle. Okay, we always plot theta first. Oh, I don't know why I put it equal there. Okay, let's always obey the angle first. So here we go, right here. Negative 11 pi over 6. So I know that positive 11 pi over 6 is here, okay, but I'm going negative 11 pi over 6, almost to negative 12 pi over 6. So negative right here. So that is my negative 11 pi, negative 11 pi over 6. Okay, that is my angle, negative 11 pi over 6. However, I'm supposed to reflect the radius. I'm not supposed to put 1, 2, 3, 4 here. I'm supposed to reflect it over. So let's make it a nice little dotted line so it's not messy. Okay, and let's reflect 1, 2, 3, 4. Our point should be here. There we go. Now, notice that I obeyed and I went to negative 11 pi over 6, but then I reflected over my radius of negative 4. Okay, it doesn't match perfectly with these little circles, the radius of 4, but I put my tally marks 1, 2, 3, 4. Okay, so please obey the angle first, then reflect it over. It can be messy, so please be careful with the messiness. Try to make things light, okay? Now, the last thing we need to learn for today is a short video is there are 3 additional equivalent polar coordinates for any given polar coordinate. Okay, so if you give me one polar coordinate, I can arrive at that same exact polar point in 3 different ways. However, you must stay between negative 2 pi and positive 2 pi. You cannot go greater than that. Okay, you can find these equivalent coordinates by reversing the direction of an angle and reversing the direction of the radius. Okay, so you can make a positive radius, negative radius. You can go rotation in a positive rotation or negative rotation as long as you don't go past 2 pi or past negative 2 pi. Okay, so for example, let's do this one, the 2,3/4 of a pi. So let me go ahead and do it fresh over here on a nice clean piece of paper. So the given coordinate is 2,3/4 of a pi. Okay, so let me go ahead and cover it. Okay, so let's go ahead and do the original, the given. 3/4 of a pi is, here's 1/4, very lightly with a pencil. Here's 3/4. So let me label 3/4. Let me arrive at 3/4. There we go. And let me count the radius of 2. 1, 2. There's point P. Okay? Now they want us to find 3 additional ways of arriving at point P without using the given coordinates. Gotta give me a different coordinate. It's kind of like, how do I arrive at her house? Oh, you can go from the left, you can go from the right, you can come from the north, you can come from the south. So I'm gonna draw the same exact point right here. 1, 2. That is exactly the same point. I just didn't label it, the location of it. Let me do one more. Here's 1, 2, same exact point. And let me do one more right here in the corner. 1, 2. Okay, so one way to arrive at this point is going to 3/4 of a pi and using the radius of 2. How can I arrive exact the same point but going in a different direction? Well, we can start from here and go in the negative direction, right? We can go in the negative direction and arrive there. What would that be? If that's 3/4 in the positive direction, what would this direction here be? Okay. That would be negative 5 pi over 4, okay, because that's negative 1/4, 2/4, 3/4, 4/4, 5/4. So that's negative 5 pi over 4, and the radius is still 2. The radius didn't change because I went to negative pi over 4, so that's negative 5 pi over 4. Okay, so I went to negative 5 pi over 4 and stay with the radius of 2. How else can I get there? Well, I can go to negative 5 pi over 4, which is right here. Okay, I can go to negative pi over 4, which is just right here. Negative pi over 4. And reflect over, okay, because that looks like a reflection. Instead of staying here, we reflect it over. So a reflection. So there's one way, another way to arrive there, and here's a second way to arrive there. And then let's come up with another way of getting there. So I can do negative 5/4. I can do negative pi over 4, negative 1/4, and reflect it over. What else can I do? Well, I can go all the way through to 7 pi over 4. Okay. I can go all the way through to 7 pi over 4. So that's 7 pi over 4. And reflect the radius over negative 2. So notice that I kept on using the same exact 2 rays, either going to the positive or going here to the negative. I just kept on arriving and calling it different angles. Negative 5/4, negative 1/4, or 7/4, and then just deciding if I need to reflect it or not. Okay? All right, kind of messy, but Helps you see it. All right, that was the 2,3/4. Let's do another one. Let's do plot the point and find 3 additional polar coordinates for between negative 360 and positive 360. So they want us to use degrees instead of radians. All right, let me go ahead and use a clear paper because I find the grids very small and confusing. So let's go ahead and plot the negative 30 degrees, which is right here, negative 30 degrees, and the radius of 4. 1, 2, 3, 4. Put the big point P right there. Let me show my direction. I came negative 30. Okay. Now they want me to come up with 3 other ones. So here we go. 1, 2, and 3. Let me plot the point, okay, roughly here. 1, 2, 3, 4. Here again, 1, 2, 3, 4. And here again, 1, 2, 3, 4. Okay, how are we going to arrive at this place? Let me write down 4, 30 is the given one. Okay, so 4, 30 is the given one. How am I going to arrive at the same exact point but calling it differently? Not the same. Okay, so I want you to think for a minute, pause, see if you can figure out as many as you can. Okay. Is it 4? Yeah, it is 4. All right. Okay, so how can you arrive there? Okay, so can you go from 0 to 330? Yes, I can. So 330 degrees, positive direction, and still the radius of 4. Okay, how else can you arrive there? Well, how about if we go to the other line that continues here? How about we go to 150 and then reflect it over? Okay, so how about we go to 150 and then reflect it over? So 150, reflect it over the radius of 4. Okay, what else can we go? What else can we do? How about we go in the negative direction but bigger? Okay, there was a small negative direction here. Let's see if we can arrive here. How about if we go right here? What would that be? Negative 210, right? So negative 210, comma, I have to reflect it over, negative 4. So go here, reflect it, you end up here at point P, check. If you go to 150, reflect it, you end up here at point P, check. If you go 330 and then stay here, that is, stay with the positive radius, there it is. Okay, so that is how you get 3 other ways of labeling the exact same point. All right? So that is the 4, negative 30. Your homework will be this guy right here. Can you come up with 3 other different ways of plotting this point? Okay, I will ask you for those coordinates. Okay, coordinate 1, coordinate 2, coordinate 3. I'll ask you for the other 3 coordinates as a little warm-up, very first point of the semester. Okay, you can plot it for yourself. What I want is the 3 other coordinates, not the original coordinate. I want 3 other coordinates, and that's homework for you. Okay, the rest we'll do in class, and we'll do an Interelastic in class as well. Okay, there we go, 24 minutes. See you later.